Welcome to organic chemistry. We're going to be now looking at the organic chemistry, which is actually my favorite branch of chemistry. Now, the organic topic requires you to know quite a few definitions. I'm not going to kind of read them all out to you straight away. I'm going to introduce them as they come. One of the main differences between OCR and AQA is that between AQA and Edexcel is that in Edexcel they require you to know isomerism, but in AQA they don't. So for those of you that do Edexcel, I will be doing a separate lesson on isomerism. Now, the first part of all of this is, what is organic chemistry? Well, organic chemistry is the study of carbon. As simple as that. Compounds containing carbon. In particular, we're going to be looking at hydrocarbons over the next few lessons on the alkanes and alkenes. In order to do that, we need to start with crude oil, what it is and how it is separated using fractional distillation. So to begin, I'd like to just introduce these definitions. So hydrocarbon is an important 2-mark question. It is defined as a compound made of carbon and hydrogen only, with the emphasis being on the word only as an extra mark, because you could have carbon, hydrogen, and oxygen, then it would not be a hydrocarbon. So you have to say only. Now, a mixture from the original lessons is when you have different elements and/or compounds which are not chemically bonded. So crude oil is going to be a mixture of hydrocarbons. That's why these two definitions are there. So crude oil equals mixture of hydrocarbons. Because they're a mixture with miscible liquids, they can be separated by their different boiling points. And that's where fractional distillation comes in, something we looked at earlier in separating techniques. Now, a compound, well, that's obvious, is when you have different elements chemically bonded. Now, this is something new, a homologous series. Now, you're going to study quite a lot of homologous series. You're going to study the alkanes, alkenes, and then alcohols, carboxylic acids, esters, and so on. I want you to think of a homologous series as like a family. It's a family of essentially similar types of compound. The actual definition contains 4 separate points. So a homologous series is defined as having the same functional group. Again, you have not yet done what a functional group is. You will see it over and over again. But for now, I'm just going to say it is the part of the molecule that determines the chemical reactivity or behavior. That is what the functional group does. It's like the most important part of the hydrocarbon. Or the compound. It's the bit that essentially means you're classified as a particular family. Okay, so kind of think of it like your surname. Same general formula. Again, you'll see what that means when we do the alkanes. Each member differs by a CH2 successively, which means that as you go from the first to the second to the third, the carbon chain extends by 1 carbon and 2 hydrogens. Now, there are actually 2 points missing here. One of them is similar chemical properties, because they have the same functional group. And the other one is similar trends in physical properties, such as, for example, boiling points increasing. So this one is similar trends in physical properties. These are basically the same or similar chemical properties. So they, for example, all react violently, or they all react by physics. So you should know all these things. So same general formula, same functional group. Each one differs by CH2. Those are 3 very easy things to memorize, because they can ask you to define a homologous series, or they can ask you to name the features of a homologous series, which means the same thing. Then you have these 2 other words, saturated and unsaturated. You will see what that means when we do alkanes, alkenes. But for now, just to introduce you, saturated means single bonds only. Unsaturated means double bonds. And we're talking about carbon ones. So this is single carbon-carbon bonds. This is double carbon-carbon bonds. We will revisit this again. This bit, though, is very relevant to what we're about to do. So volatile means how easily you turn to a gas. You might have heard of someone saying that, I don't know, your friend is a volatile person. That means he's quite aggressive. So that means his temper is low and it turns to a gas easily. Viscosity means how runny something is. So water would have a low viscosity because it's very runny, but toothpaste would have a high viscosity because it's gloopy or thick. With those words in mind, we're going to move on to not alkanes, but we're going to start with the crude oil topic. So the crude oil is here. How do we separate crude oil and what is crude oil? So you need to know that crude oil is a mixture of hydrocarbons. That's the definition. Remember, mixture means not chemically bonded. Hydrocarbons means only hydrogen and carbon atoms. Now, fractional distillation will take the crude oil and separate it into different fractions. So this is a fractionating column, and these are the different levels. They're called fractions. So you start off with crude oil from the ground dug up, and I'll kind of explain how this thing works. Then I'll show you an easy way to remember the key points if you're asked an exam question. I mean, the typical exam question would be, what is fractional distillation? How is it used to separate crude oil? It can be worth 3 to 4 marks. I'm just going to talk about how it works first. So the crude oil is heated, dug up from the ground and heated. When it gets heated, it gets vaporized or boiled. It then goes into this fractionating column and rises up as a vapor. As it rises, it cools. The fractionating tower is hottest at the bottom and cooler at the top. So it has a negative temperature gradient. As the vapor rises, it will cool and condense at its boiling point. So remember, the boiling and condensation point are equal. So for example, the diesel, once this is say 300 degrees here, as it rises, it cools. Once it reaches 270, it will condense. It will cool and condense, and it will be siphoned off as a diesel, which will just siphon means it'll just come off as a liquid there. It'll be tapped off basically. Now, as you can see, the lowest boiling point one is at the top. That's the shortest chain, the smallest molecule. The largest one will be at the bottom because it'll have the highest boiling point. So we'll need to talk about these trends and the reason for them. The thing to note is that you'll need to know the order in which these come off and what their uses are. In your syllabus, you'll need to know refinery gas is the first one that comes off. Then you have something called, all these two, gasoline. You might see it written as gasoline. So instead of learning 2 separate ones, you can just learn gasoline for these 2. So refinery gas is used for the cooking stove if you're still using gas, or the Bunsen burner. It is essentially methane. You can also use it in these kind of containers that you have to turn on the tap. The gas comes off, you light it with a splint or with a match or a lighter. Then you got kerosene you need to know. Okay, that's used for planes. Diesel, cars and trucks. You don't need to worry about this one. Fuel oil used in ships. And lastly, bitumen used for road surfaces. So 1, 2, 3, 4, 5. You need to know the order in which they come off and one use for each. So before I look at the trends, I'm just going to show you a very easy way to remember all of what I just said. The way to remember it, it's written in the short notes. Remember, I have these notes attached as well. So these are the common questions and answers notes that you have access to. They actually have all these key things written here. So what's a hydrocarbon? Here it says same chemical properties, similar trends in physical properties. These are all correctly taken from mark schemes. So these are the words you want to use. Now I'm going to show you how to remember this one in a simple way. And this is the perfect exam answer. You see here I've written them all in order with a use for each. But to remember this, I tell people, remember HVCC. HVCC. heat, vaporize, cool, and condense. That guarantees you 2 marks, HVCC. Then you need to say the fractionating column is cooler at the top and hotter at the bottom. That will be a 3rd mark. Okay, fractionating column is hot at the bottom and cooler at the top. That's the 3rd mark. And I would add, to make sure, for a 4th mark, that long chain hydrocarbons collect at the bottom because they have high boiling points. Now, the reason for this is actually written here, but we're going to discuss it. So do not worry about that just yet. So in summary, HVCC, cool at the top, hotter at the bottom. Long chains collect at the bottom due to having high boiling points, and short chains get siphoned off at the top as they have lower boiling points. Now we're going to talk about the trends and the reasons for this. So if we go back to the kind of more in-depth notes, here, these are the trends. What you can see here is, as the molecule gets bigger, so from left to right, the boiling point goes up. Because the boiling point is going up, the flammability goes down. So the arrows point the other way, because the short chains are the most flammable. Flammable means how easy it is to burn, volatile, how easy it is to turn to a gas. So because this one is increasing, both of these are decreasing from left to right. So subtle difference. Volatility means the tendency to turn into a gas, and viscosity means, flammability means how easily it burns. So they're quite similar, but not the same, but the same effect. Now, why is that? Well, imagine you have a short chain. I've drawn 2 molecules next to each other. These will be the intermolecular forces between them. I, M, F. Remember, intermolecular, between molecules. You've met that before when we did simple molecular structures in the covalent bonding topic. Now, picture for the long chain that you have many more carbons. Can you now see how there's many more intermolecular forces, which makes them stronger? So for an exam setting, you can just say long chain molecules are bigger, so they have stronger intermolecular forces, therefore require more energy to break. So I can write that here for you. Larger molecules have stronger intermolecular forces, require more energy to overcome. That's the reason boiling point goes up. That's the reason volatility goes down. That's the reason flammability goes down. And also is the reason viscosity increases. Because more viscous means more thick, which means it's not flowing as easily. And that's because the longer chains are more strongly attracted, so it's not flowing as easily. An extra point, the longer chains, because they don't burn as easily, they produce smoky flames when they do burn. That's a sign of incomplete combustion, which is coming up very soon as a topic. Okay, so to summarize all of this, remember you have the short notes. And my recommended method for revision obviously is I'll make a separate video on it, but it's to cover up this answer and see if you can say it out loud yourself from memory. So we've done down to here now. So what happens to boiling point and viscosity? Well, they both increase because the IMFs increase, which require larger energy to break. The last thing is, as the molecules get bigger, they get darker. That's just a physical property. Okay, so that takes us through the basics of that. And the next thing we need to talk about, I would say the next thing to talk about would be what the alkanes actually are. And then we can look at the combustion effects. So that's how we're going to divide up the lessons. So for today's lesson, we've done crude oil. And the purpose of crude oil and undergoing fractional distillation is to produce these. And all of these are called alkanes. So in the next lesson, we're going to look at the alkanes. So see you then.